that you've seen the setup for mixed reality capture, I'll change gears and introduce you to the game engine integrations. This will give you a better idea of how to add mixed reality capture into your game and things to watch out for to enable a better capture experience. Now, integrating mixed reality capture, or MRC, into your game is a straightforward process. If you're familiar with using our Unity and Unreal Engine 4 integrations, you're already well on your way to adding mixed reality capture support. All the functionality is included with our integrations package as of the 1.38 release. Now, starting with Unity, the MRC feature is included in the latest OVR plugin and Oculus integration scripts. It's enabled through the OVR camera rig prefab and the OVR manager script. When mixed reality capture for quest setting is set to automatic, which it will be by default, MRC will be enabled. The integration uses the camera configuration from the XML file to then add an in-game camera, matching the configuration to capture the MRC view. This camera is fully controlled by the integration script to follow the OVR camera rig that it's attached to. If your Unity project does not use the OVR camera rig and or the OVR manager script, you will need to make some small changes to your application, but you can continue using your own scripts and components for the rest of your game. Simply add the following code snippets into your system components awake event. This part will add the OVR manager's component and sets the tracking origin to 4 level, which allows the MRC camera alignment to be correct. This next part adds the OVR camera rig, but disables it specifically for the eye camera, which allows you to continue using your own camera setup for the in-headset VR rendering. A more verbose version of this code snippet is available on our documentation page for Quest MRC if you would like to add MRC to your game while still using your own camera setup. Although UE4 is a very different engine, the MRC story there is quite similar. It's enabled just with the Oculus VR plugin. So if you are using a compatible plugin, you should have MRC available out of the box. The MRC part of the plugin automatically reads the camera configuration and handles the network connections. When connected, it will automatically add a scene capture 2D to render the MRC view, which will, by default, follow the first VR player pawn in the game. The position and configuration of the scene capture is controlled by the plugin, according to the camera configuration from OVR plugin. Now, you may not always set up your player character the same way, and in some cases, the automatically selected tracking reference, which is the first player pawn, may not be the correct component for you. Depending on your player setup, this may be offset from the actual tracking origin. For this case, we provide a set tracking reference component function, which allows the MRC tracking reference to be set to the correct component according to your setup. Now, let's dive deeper into the MRC integration into the game engines. This is the original diagram that we showed, and we'll be looking at the Quest app section. Now, MRC is currently built into our Unity and UE4 integrations, starting with OVR plugin. To enable MRC capabilities, OVR plugin first checks for the MRC XML configuration file, and that it exists on the device. If it doesn't, MRC is not enabled, and the app runs as usual. If it does, then OVR plugin starts listening for a connection request from OBS. With that, the connection is initiated from the OBS side, and that connection gets accepted by OVR plugin. With that, in the engine, the Oculus MRC module confirms with OVR plugin that MRC is enabled, and if so, pulls the connection status. Once the connection is established, the MRC module starts setting up the game. To set up the game for MRC, the Oculus integration creates a virtual camera, configures it with the properties from that camera configuration, starts the audio listeners, and aligns the virtual camera with the physical camera every frame using the data from the camera configuration. The virtual camera then captures the game world for every video frame, producing a foreground capture and a background capture. The background capture, as Xiang mentioned, contains the entire scene, while the foreground capture is clipped at the camera distance with a transparent background for composition purposes. The camera then sends the foreground and background captures to our MRC integration, which combines it then with the audio data and sends that to OVR plugin. From here, OVR plugin does a final render to format the textures as needed, and then which is finally encoded and sent to the OBS plugin to be composited. Now, due to performance limitations of both the Quest and the wireless connection, we needed to make a few optimizations for Quest MRC to run smoothly. One thing we noticed was that the horizontal resolution of the video generally feels less impactful for visual quality than the vertical pixels. To reduce the GPU load of the additional camera, we reduced the horizontal resolution of the capture to 1280 by 1080 while keeping the aspect ratio, and then upscaling back to 1920 by 1080 on the OBS plugin. For the foreground, we specifically needed the alpha channel to do composition on OBS, which made things a little bit more difficult since the H.264 encoder only encodes RGB. So to get around this, we actually encode an RGB image as well as a separate alpha image. Since there are generally few objects in the short distance between the mixed reality camera and the player, we actually found this acceptable to have the horizontal resolution again to 640 by 1080, therefore reducing the network load of streaming the video. Now, another thing that we found was that the 72 Hertz refresh rate doesn't actually translate perfectly to 30 Hertz video. As a result, when MRC is enabled, we support switching the screen and rendering to 60 Hertz mode to allow for a smoother video than 72 Hertz. This has the added benefit of allowing more rendering headroom, as only 60 frames need to be rendered per second, both in headset and in the MRC camera. However, this does introduce a bit more flickering, and not every game will play well at this refresh rate. So we are planning to provide the option for games to run at either refresh rates when MRC is activated. To further improve this, we actually render alternating frames of foreground and background. This halves the number of frames that we need to render and send, which is significant both in terms of rendering cost and network bandwidth. The result is a half frame rate video from what you see in the headset, with a slight offset between the background and the foreground frames, which we also found to be acceptable for viewer experience. Now, while we did try to make the implementation as simple as possible for you, there are some things that you should keep in mind when developing your app for mixed reality capture. First, make your environment compatible with the third-person camera view. Leave some empty space around the player to avoid obstructing the MRC camera, or make them visible only to the VR camera. Also, the MRC camera can be showing things behind the player's head, so make sure that the environment behind the player looks good as well. Second, make sure your app is flexible when rendering visual effects. As you saw in the optimizations that we made, there are a number of differences between the iCapture camera and the MRC camera. So design your visual effects to be compatible at different resolutions and aspect ratios. Have any interfering HUD elements, UI components, or body models visible only to the VR camera so that they don't conflict with the camera capture in MRC. Third, you'll want to find the right tracking origin. Even though we do our best to automatically select the correct tracking origin, you have all the insight into how your game works and how it's set up. If you make any changes to the camera rig in Unity, or use a different player component set up in UE4, the default tracking origin for the MRC camera can be incorrect, which causes the game capture and the real-world capture to be misaligned. So make sure you do find that correct tracking origin if the default doesn't work for you. But really, the most important thing is to test your app with MRC enabled. You'll want to make sure that all of these considerations are working in your final build, and that your app looks how you want it to look in mixed reality from a variety of different camera positions. You'll also want to make sure that your app is still hitting the frame rate with MRC running, and that the performance, both in headset and in MRC mode, is still up to your expectations. So if you're ready to add MRC to your next game, and you're using Unity or Unreal Engine, all you need to do is grab the latest Oculus integration from the Asset Store if you're a Unity developer, or our latest UE4 fork from our Oculus GitHub page if you're an Unreal Engine developer. And we look forward to seeing what you can do with mixed reality capture. With that, I'll send it back to Xiang to take you through what's coming up next with mixed reality capture.
Thank you, Kevin. I can't wait to share with you what would come next. The current MR capture flow is developer-centric. In the future, we want to provide the tools for the wider audience, especially streamers and influencers, so they can easily make MR footage from their favorite VR games and share them with the community. Our upcoming mixed reality capture client would have a fully redesigned UI. It will provide much better MR capture user experience, and it will support both Rift and Quest. MRC is great, but that doesn't mean it's the best choice for any kind of content. If a game features customizable avatars, we may prefer to capture the player's virtual image instead of their real-world image. We are going to support third-person camera. There will be new APIs to support developers placing the virtual camera on any chosen position. The virtual world will be rendered through that camera and then streaming to OBS through the same MRC workflow. Kevin presented how MRC is integrated to Unity and Unreal engines. However, we understand that not everyone uses one of those game engines. We are going to ship a standalone MRC library to support native developers to add MRC to their own titles. The library would include every feature which our Unity and Unreal integration supports. We will deliver the library before the end of this year. Assuming that you have integrated MRC to your app, let's take a look on how to get started for shooting mixed reality footage. Here is a list of everything we will need in the mixed reality capture. I won't explain much about the Quest headset since you all know what it is. We will need a Windows 10 PC for running OBS and connecting the camera. It won't have to be a super high-performance computer. A gaming laptop would usually work well. The wireless router is important. Because we connect the Quest to the PC through Wi-Fi, the connection quality matters. It's recommended to use a high-quality wireless router for this task. We also need a green screen for the background removal. If your capture environment doesn't have a great lighting condition, it will be useful to set up a few photographic light lamps to get more brightness, and also remove the shadows. Of course, we also need a camera. Any high-quality USB or HDMI camera would just do the job. It's recommended to get a camera which can output 1080p at 60 fps. You also need to download our Oculus Mixed Reality Capture tools from the Oculus development website. The toolset contains all the components that we will need to set up the capture workflow. I demoed how to use them previously. We are also going to put a blog post which would cover everything you will be interested in. Please stay tuned. MRC is important. However, getting a perfect integration is not trivial work, since we need to make sure all the content still looks perfect from a third-person camera. We are working with a few great titles to enable this feature in the perfect way, including Beat Saber, Superhawk, and Dead and Buried 2, which would all get MRC in our future updates. However, there is no need for you to wait. Please don't hesitate to integrate MRC to your own game and let us know how it goes. Thanks everyone for coming to the talk. Kevin and I would be in the pavilion for the next 30 minutes. If you have time or have any questions, please join us.